Hello everyone, my name is Yash Kohar. So today I'm here to present my analysis on the very famous machine learning dataset called Iris dataset, and it will be a classification problem. So let's start. So first of all, let me introduce you to the dataset and the problem statement. So Iris is a kind of a flower. So it has a sepal and a petal. So as it is clearly seen in the diagrams, and depending on the length and the width of these two, the flower is categorized into three categories. First one is the iris setosa, then iris versicolor, and iris virginica. And this is a data set given to us, so it has these six columns. So first one is the id, that is a unique id of each observation, then sepal length, sepal width, petal length, petal width, and in the end we have the species. So our job is to create a model that will take into consideration these four features of the data, and it will classify the flower belongs to which category or which species. So first of all, we did some high level analysis on the data set given to us, and then we did some cleaning on that. So the data set consisted of 150 observations. So it has 50 observation of each class of the flower. Then we had four continuous features and one categorical features apart from the ID. So ID was not very useful for us for the analysis, so we have dropped the ID column, and also there was no null or missing values in the data set, so we didn't need any further cleaning of the data after that. So next we move on to EDA part of our data set. So EDA stands for exploratory data analysis, and the first graph we are seeing is a histogram. It's univariate because only one feature is taken into consideration at a time. So I've created four charts for it on all the four features. So first of all, we'll see the petal length in centimeter feature. So as you can see, the x-axis consists of all the petal lengths and the y-axis consists of the frequency. So histogram just shows us the distribution of flowers as per the petal length in this chart. So if you can see for this length, we have almost 37 to 38 flowers. Then for the second length, we have almost 13 to 14 flowers. So in this way, it shows how the 150 flowers are distributed as per the lengths of the petal, then the petal width, sepal length, and sepal width. So the next chart we see is called a Vining plot. So Vining plot got its name because of the shape of the plot, and it shows the probability density of the data at different values. So as you can see, there's a box plot inside this chart. So the box plot shows the distribution, how the data is distributed as per the sepal length. So this the bottommost part is the minimum value, then we have 25th percentile, then median, then 75th percentile, and then the last the maximum value. So apart from this yellow part which is shown, that is called the probability density of the data at different values. So for example, if you can see, the farther the yellow part is from the middle box plot, the more the probability density of that data at that value. So in this way we can figure out how the values are distributed as per the density. So the next type of chart is called scatter plots. So it's an example of bivariate analysis because two variables are analyzed at a time. So we had four features in our data set. So we have created four charts out of it by taking different combinations of the sepal and petal widths and lengths. So normally for a classification data set, we expect some kind of clusters formed. But if you can see the first chart, Setosa is well separated, it's forming a separate cluster. But the iris virginica and iris versicolor are kind of overlapping. So if you can see other charts also, again the Setosa are separated and virginica and versicolor are quite overlapping. But as compared to the first chart, the other three charts are quite uh, well separated from each other. So they are forming different clusters with some errors. So the next type of chart we are seeing is called a heat map. So it's an example of multivariate analysis because all the features in the dataset are analyzed at a time. So it depicts the correlation between the features with different color shade as for the correlation values. So as you can see in the heat map, we have all the four features in the x-axis as well as in the y-axis, and the values inside the matrix, its correlation values, and normally it ranges from -1 to 1. -1 means highly negatively correlated, and +1 means positively correlated values. So any value around 0 means weakly correlated. So as you can see the diagonals, they are always 1 because everything is correlated with itself. And after 1, the highest value we can see is of the relation between petal width and petal length. It's 0.96. And after that, it's between petal length and sepal length. So it also shows the color. So colors intensity determines the correlation values as per the scale which is shown in the right side. So the next type of chart is also a multivariate chart. So it's called a pair plot. So it's a kind of a combination of scatter plots as well as the probability density function. So in the diagonal, we can see the probability density functions, also called as PDFs. So they're nothing but the smoothened version of the histograms. And in the non-diagonal, we can see the scatter plots, which it's like what we had seen earlier. So it shows how the data points are scattered across the two features. So they are just showing all the combination in a single plot. So after the EDA part of our dataset, we are moving to the model creation. So before creating the model, we make our data ready for it. So we follow some steps before that. So the first one is the label encoding for the categorical variables. So in our dataset, we have one categorical variable called a species, the target variable. So we are converting it into numerical form so that it will be easy for computations. So we are using the label encoder function for that. Then we are splitting our data set into train and test split. So suppose we have 100 records, so it will be separated. 80 will be in the train data set and 20 will be in the test data set. So after that we'll do the scaling of our X data set. So we are using the standard scaler for that. So after that we are going to create the model. So I have created 5 models. First is the logistic regression, then KNN, decision tree, SVM with polynomial kernel, and SVM with linear kernel. So I have created these with these hyperparameters. So after evaluating the results of our model, we found out the accuracy scores for each model. So for logistic regression, we got an accuracy score of 96.67. For KNN, we got 100. Then decision tree, we got 96.967 again. And again, same for the SVM with polynomial kernel. And for SVM with linear kernel, we got 100 accuracy score. So in the end, let's conclude our observations and results from our analysis. So our iris dataset was not a very huge dataset. It consisted only of 150 rows and 6 columns, and all the three species were equally distributed uniformly in the dataset. That is 50 rows for each. Then the petal length was highly correlated with the sepal length and petal width features. Then we tried the 5 different machine learning models on the dataset to classify the flower into 3 species based on the length and width of the flowers, petals, and sepals. And with some hyperparameter tuning, we got a very high accuracy for almost all the models, and even an accuracy score of 100 for KNN and SVM with linear kernel models. So that's it from my end about the Iris dataset analysis. Thank you.